So kinematics is the branch of physics. It is the branch of physics that deals with the branch of physics which deals with motion. Without going detail about its cause. Okay, so without going details about its cause, if we discuss the motion of a body, then this branch of physics is known as our kinematics. Okay, but if we go deeper into the motion and if we discuss about the cause, this is called our dynamics. Dynamics means motion. If we discuss motion along with its cause, okay, then this is known as a dynamics. So when we talk about this motion, we have to understand what is this quantity called motion. Motion means if a body changes its position with time. How do you understand by this? Suppose let us see a body is moving like this. Suppose initially it was at position A and after some time it is here at B. It is its initial position. This is its final position. Means it is moved from here to here. That means the body has changes its position from A to B. That means the position has changed. So we can say that this body is in motion. Okay. Then when we talk about this motion, then another quantity comes that is called rest. Means the body doesn't change its position. That means if the body is at, suppose the body was here at t equals to 0 in position here, after suppose t equals to 30 seconds, we see that the body is again here. T equals to 30 also, the body is again here. So here the body doesn't change its position. So in this case we can say that this body is at rest. Okay, but here we see, when we say that this body changes its position or doesn't changes its position, how can we determine this one? Means, so to determine whether a body is at rest or in motion, that means if it has changed its position or not, we have to measure these points with respect to a certain point. Okay, and this is known as our origin, from where we measure the position. Suppose this position, okay, we measure this quantity. Initially also suppose it is here, and after 30 seconds also we measure that. Again this distance is suppose same. Then we can say that this body is at rest. But here what is happening? Suppose this is my origin initially I measured this body was at here, but after some time I measured that this body is at here. Means the position of the body has changed from here to here. So for measuring this position and all these things, we need a origin point. Okay, and this system of coordinate axes, these are called axes. Okay, these are called our axes, and this system of axes along the origin, it is known as a frame of reference. Okay, it is known as frame of reference. So a frame of reference looks like this. Okay, this is my x-axis, y-axis, z-axis, and this is my origin O. So from here, wherever the body moves, I have to means I can easily measure the distance or time or anything I want to measure. I can measure from here. Okay, so this is my reference frame, or also called frame of reference. Frame of reference. Okay. Now up to here I think it is clear. Now let us see what is absolute rest and absolute motion. Absolute rate and absolute motion means here my reference system, my origin of the reference, of the frame of reference. When I am writing in capital letter, this means frame of reference is fixed. Okay, if my frame of reference is fixed, then whatever I measure from here, it is absolute value. It will give me absolute value. Means this frame of reference should not be moving with respect to the body. Okay. So in this case, if my frame of reference is fixed, or the origin of the frame of reference is fixed, then this rest and motion of the body is known as absolute rest and absolute motion. But in our everyday life, we know that the earth is moving around the sun and the sun is again moving around itself. So whatever we are measuring, we cannot say that the distance or the motion of the particle observed, it is absolutely at rest or absolutely at motion, because there is already some motion involved with the frame of reference. Because our frame of reference, we have to fix some point around in the earth, and the earth itself is in motion. So whatever we are measuring, these are not absolute quantities, they are relative quantities. Okay. Now let's talk about this coordinate system. Okay. Let us discuss about this distance and displacement. Okay. Suppose a body starts its motion from a position A and it goes like this from here to here and reach here at position B. Okay. So in this case, the body, it goes like this from here to here, again from here to here. In this way it goes from A like this and reaches here at B. Okay. So if we measure the length of the path from here, then it goes like this. The total length total length covered is known as a path length. Means the length covered by the body during its motion. If we name it like this, suppose it is A, C, D, E, F, G, H, then this motion, the total length will be A, C, D, E, F, G, H, and at the end it will reach at B. So the total path length, it is also known as the total path length. The length of the path, it is known as our distance. Means the total length covered by the body during its motion is known as distance. Means it will be from here to here, this length plus this length plus this length plus this length, the total length. It is known as our distance. Whereas the displacement is the length between the initial position and the final position from here to here, B. Means the distance between the initial and the final position. From here, from A to B, this distance is known as our displacement. So displacement is always a straight line. It is always a straight line. Where is this path length or distance? It can be a curved line. Okay. So the displacement is always a straight line. याद रखो इसको, displacement is always a straight line. Okay. So how can we define this distance and displacement now? So the distance is the total length covered during its motion is known as distance, whereas displacement is the distance between only the initial and the final point. It doesn't depend upon the path along which the body is moving. Okay. And if the body is moving, suppose in a straight line, suppose body is moving from A to B along a straight line, then in that case your displacement and distance will be same. Okay. So the magnitude of the displacement will be equals to your distance. Okay. And another thing, this distance, it is a scalar quantity, whereas this displacement, it is a vector quantity. So the scalar quantity and vector quantity, what do you mean? We mean that scalar quantity means for distance there will be only a magnitude, whereas for this displacement there will be a magnitude as well as a direction. So in this case, the direction of the displacement will be from A to B, here to here, this along this line. Okay. Whereas for this distance, only the total length covered, only the magnitude, the value only will be specified. Okay. So this is the main funda about this distance and displacement. Okay. Next, we'll discuss about this. Discuss about speed and velocity. Okay. What is speed? The speed is the distance covered per unit time or distance covered per second. Whereas my velocity is, it is displacement per unit time or displacement per second. Okay, so from here we can easily identify that as distance is involved here, so my speed it is a scalar quantity, whereas this velocity as displacement is involved, so it is a vector quantity. Okay, then what is the unit and dimension? Velocity, my unit will be displacement per time. So my velocity equals to, I know that displacement by time, so my unit will be meter per second, centimeter per second, etc. And same as for the speed also. What will be the dimension? Dimension equals to, we know that for this displacement it is L1 and for this time it is T, so this means it will be LT minus 1 or M0 L1 T minus 1. Okay, so if someone asks you, then what is the unit and dimension of speed or velocity, then what will be the answer? The unit will be meter per second or centimeter per second or kilometer per second or kilometer per hour, because bigger units of time are the second, minute and hour. It is meter per second, centimeter per second or kilometer per hour or kilometer per second, kilometer per minute, like this. But the dimension will be, right? We can say that LT minus 1 or M0 L1 T minus 1. Okay. So what is the useful formula? Here is velocity equals to my displacement by time. Okay. Or speed equals to distance by time. Keep these two formula always in mind. Okay. Next, this velocity can be of two types. Two types of velocity. That is, first is uniform velocity, second one is non-uniform. What is uniform velocity and what is non-uniform velocity? If the body covers equal distance in equal interval of time, if the body covers equal distance in equal interval of time, then the velocity of the body is said to be uniform velocity, and for non-uniform, if the body shows unequal distance, if the body covers unequal distance or unequal displacement, here also displacement, okay, make it displacement. Displacement in equal interval of time. Okay. Next, average velocity. Next, let's discuss about average velocity and instantaneous velocity. Okay. Suppose, let us understand this like this. Suppose a body starts its motion from a point here at A and it goes up to B. Okay. So the total displacement of the body is from A to B. Total displacement equals to AB. So now it is vector quantity A, B. So suppose it is given that from this point to this point the total time taken is t1 and the distance from here to here t2, t3, t4 and this one final t5 or tf, t final. Okay, this is my t initial, t equals to 0 or t initial, and suppose here the distance covered, suppose let's name it as C, D, E, F. So in the time t equals to 0 to t to the t equals to t1, the body has covered distance t1, and from t1 to t2 it has covered distance CD, like this. T2 to t3 it has covered this, like this. T3 to cut this distance and t4 to final this distance. Okay. So the total displacement AB in this case equals to my SC plus CD plus DE plus EF plus FB. So the total time is from t equals to 0 to t equals to tf, that equals to tf minus t0 or ti, we can say. Let us take it ti. Let's suppose let it be t, say. So my velocity will be in this case total displacement by total time. So this equals to my total displacement AB divided by total time T, or that equals to my final position, means this final position minus initial position divided by this TF minus TI. Okay, or we can say the final position, let it be suppose B minus A divided by T final minus TI. So this is the average velocity. Means to find the average velocity, this means average velocity. Okay. So to find the average velocity, what we need? We need only we need to know the total displacement. मतलब बॉडी कितना डिस्प्लेसमेंट हुआ है बॉडी का, एंड द टोटल टाइम टेकन, कितना टाइम लिया है उतना डिस्प्लेसमेंट के लिए, एंड इफ वी डिवाइड बोथ ऑफ देम देन वी आर गेटिंग द एवरेज वेलोसिटी. ओके, then what is the instantaneous velocity? Suppose instead of finding this average velocity in the whole region, suppose we are interested to find the velocity here at suppose t2. It's at t2 second, what is the velocity? So in this case, what we have to do? So okay, let me simplify it a bit. Okay, so instead of making this much point, let us make it like this. Let us consider only 2 points. Okay, the body has gone from here to initial position. This is my initial position, and this is my final position. Okay, here at T1 and T2. So V average equals to my final position, my initial position. This is my displacement by T2 minus T1. Okay, or we can say, if this is final position, suppose this is x2 and this is x1, then this is my x2 minus x1 divided by T2 minus T1. Okay, suppose now I am interested to find the velocity at this position T. So in this case, what I have to do? In this case, suppose let us make this point T1 instead of this point T1, and we have to make these 2 points very close. Okay, stop it here. Will be from A to B, here to here, this along this line. Okay, whereas for this distance only the total length covered, only the magnitude, the value only will be specified. Okay, so this is the main funda about this distance and displacement. Okay, next we'll discuss about this speed and velocity. Okay, what is speed? The speed is the distance covered per unit time or distance covered per second. Whereas my velocity is, it is displacement per unit time or displacement per second. Okay, So from here we can easily identify that as distance is involved here, so my speed it is a scalar quantity, whereas this velocity as displacement is involved, so it is a vector quantity. Okay, then what is the unit and dimension? Velocity, my unit will be displacement per time. So my velocity equals to, I know that displacement by time, so my unit will be meter per second, centimeter per second, etc. And same as for the speed also. What will be the dimension? Dimension equals to, we know that for this displacement it is L1 and for this time it is T, so this means it will be LT minus 1 or M0 L1 T minus 1. Okay, so if someone asks you, then what is the unit and dimension of speed or velocity, then what will be the answer? The unit will be meter per second or centimeter per second or kilometer per second or kilometer per hour, because bigger units of time are the second, minute and hour. It is meter per second, centimeter per second or kilometer per hour or kilometer per second, kilometer per minute, like this. While the dimension will be my we can say that LT minus 1 or M0 L1 T minus 1. Okay. So what is the useful formula? Here is velocity equals to my displacement by time, okay, or speed equals to distance by time. Keep these two formula always in mind. Okay. Next, this velocity can be of two types. Two types of velocity. That is, first is uniform velocity, second one is non-uniform. What is uniform velocity and what is non-uniform velocity? If the body covers equal distance in equal interval of time, if the body covers equal distance in equal interval of time, then the velocity of the body is said to be uniform velocity. And for non-uniform, if the body shows unequal distance, if the body covers unequal distance or unequal displacement, here also displacement, okay, make it displacement. Displacement in equal interval of time. Okay. Here we will study another physical quantity called acceleration. So what is acceleration? Let us understand it this way. So we must have listened in our daily life that whenever we are in a vehicle, moving in a vehicle, we commonly use that in गाड़ी को थोड़ा accelerate करो, गाड़ी को थोड़ा accelerate करो. When we say that accelerate means, that means what we are meaning here? Means increase the speed or velocity. Okay, so this is what we mean when we are saying that accelerate karo. That means that increase the speed of the vehicle gradually. The same way we can define acceleration as rate of change of velocity if you express mathematically, then we can write here that acceleration A equals to del V by del T. Okay, suppose a body was initially at here and it is moving to some point here, it is T equals to 0. So here at T equals to T1 some velocity V1 and T equals to T2 it acquires some velocity V2. Then we can write the average velocity, the average acceleration average equals to del V by del T. Means we can write here V2 minus V1 divided by T2 minus T1. Another quantity is there, that is called instantaneous acceleration. Instantaneous acceleration means we are interested to find the acceleration at some instant. Suppose at this point we are interested to find the acceleration. So what we have to do? Then we have to make this interval, means this T2 minus T1 very small. Means instantly we want to measure. Instantly we want to measure. When we say instantly, that means we make this del T tends to 0. So the instantaneous acceleration, a instant, we can write it mathematically as limit. Let us make this time interval to 0. We can write again the same formula, del V by del T, that equals to or we can write it as dV by dt. Okay. Now acceleration, these acceleration are of two types. First is it is called positive acceleration. Second is negative acceleration. Positive acceleration means when we know that this acceleration equals to my del V by del T, that equals to V2 minus V1 divided by T2 minus T1. For positive acceleration is this del V, it is greater than 0. This implies V2 minus V1 is greater than 0 or V2 is greater than V1. So the final velocity is more than the initial velocity. But in this case the reverse, that is V2 is less than V1. That means the velocity of the body is gradually decreasing. Then we can say this as negative acceleration, or sometimes it is called also retardation. Okay. Now we see here that this acceleration A equals to del V by del T. So how can we find this acceleration from the Vt graph? If we plot a Vt graph, T and this is V, then so it is like this. For an accelerated body, we can see that here the velocity of the body is going on gradually increasing. That means it represents positive acceleration. Positive acceleration. So how can you find the acceleration? You see that here del V by del T. So my del V is this one. Suppose I am interested to find the acceleration here. So my del V, because it is a straight line, if I take this slope, it will be same everywhere, and this slope will give me this acceleration. So this is del V and this is del T. So tan theta equals to my del V by del T. So the slope of Vt graph gives the acceleration.